I have been rejecting requests to do PCB manufacturing review videos for quite a long time now, because I've been always saying that I do, one-off projects. I usually work on a prototype board, just like this one. So I never really, need to do any PCBs. And I think that's still true, but a friend of mine asked me to build him a couple of temperature sensor nodes, and he asked for 10. And I thought that, well, that's the point where I need to do a PCB, because, well, I can't just do 10 on a perf board. It's going to be too time consuming. And so I thought, okay, I should do it. I should learn how to design a PCB. And I just picked up the first email that I got back in the day, and that was from PCBWay. So I contacted them. I asked them if they still would like to do a review video with me. So they said, yeah, no problem. But I figured that maybe as a first project I should do something on my own, just to make sure that I do everything right before I order let's say, the production version. Well, this is a different project. So what I have here is, let me actually show you, it's a station announcement board kind of thing. So I will be building a layout for, a train layout for my kids, or with my kids. We'll see how it turns out. And I thought it would be fun to have something on the layout where they can do station announcements, like express train is arriving on platform 1, something like that. So I've put this small project together, which is basically just an Arduino Nano. I have a JQ650, so 6500, is it? Yeah. MP3 player module and an OLED display and rotary switch and a couple of buttons. And what I can do here, I just done a really simple script where you can specify that in a couple of steps, what is the announcements that you want to place. So what sort of signal, I mean, this is going to be Hungarian, so it's hard for you to make any sense of it. So, okay, I want, the standard signal. I want the train type is going to be, commuter train or express train or intercity, and leaving or arriving, I think it's, leaving from platform 1, 2, and 3, and another announcement, for example, please mind the gap, the train only consists of non-smoking cars, stuff like that. And once gone through all the steps, a couple of steps where you select the option via rotary screen, then the playing starts. So I've drawn up the drawings for this board, and they arrived from PCBWay. So I'm just going to look at it now. I've ordered 10, even though I'm most probably not going to, build 10 of these. And as you can see, it's wrapped. So if I open this up, if I try to, okay, pretty tough packaging, I would say. Okay, so, and this is really my first PCBs. I've never done a PCB before. I've never used the etching method, the home brew, way of making PCBs. And I think it turned out to be pretty nice. So I haven't really figured out how I'm going to do this type of sort of like PCB soldering videos, because that's going to be the first one. So the camera is upside down. But I think you can see the general layout. So I have the Arduino here, and then I have the OLED display, the sound module, and the rotary switch, and the 2 buttons there. And I've left quite a bit of footprint around the display, because eventually I would like to get at least a 1.3-inch display. But I just had some issues sourcing them, because it turns out that these new 1.3 inches, they usually come with the not the SS1306 or SSD1306, but a different chipset, so they need a different program. So I'm using 096 for the time being. And I put all the signal traces on this side and on the back side. So obviously it's a 2-sided PCB. I use the power wires, so ground and 5 volts. And as you can see, I've even made the power traces a little bit thicker than the data traces. and I've managed to do a via as well. So as you can see, I have two lines leaving the PCB and they go to the via and they come on the other side and then they join the sound module. Okay, I just have to make sure that it doesn't get too much reflection. And honestly, for somebody who is completely new to this, I don't really know what to say about, you know, PCBs. They turned out to be exactly the way I wanted them. You know, it's nice. The silk screens are really, really nice, and I can see these really small prints here. Everything is very, very clear. So let me show you some close-ups. So everything is really, really clear. You can see that. Oh, by the way, that's the entire board. So the outlines of the different components, they came from the component package, so I haven't done any of that. So the only thing I've really added is all the different you know, markings here. So the power, you can see the V in, 5 volts and ground, and I think I've specified these smaller fonts to be 1 millimeter high. Maybe it's 1.5, but anyway, they are clearly visible. It's really easy to read them. Also, I did some text which says station announcement version 1.0, you know, left and right switches, a couple of connections. I've replicated everything as it is on the breadboard. The only other thing I've done is I've noticed that based on where you source from OLED displays, the pins are either ground VCC, SCL and SDA, or VCC ground SDA and SCA. So what I've decided doing is I've added these jumpers here. So you can use these jumpers to set whether the first pin receives ground or 5 volts and the, you know, the second pin again ground or 5 volts. So you can use the pins here, and then that's your main power input. And I've also routed out the speaker and the amp connections to from the MP3 modules into separate headers. So if I just want to hook up a speaker, I would use this connection. If I want to have a separate amp as well, I can use the amp output. If I look at, well, there is not much on the other side. So I was thinking about doing, maybe adding a bigger ground plane, but yeah, I just wasn't sure. I mean, honestly, this is my first board. And I've never learned designing PCBs. Haven't, you know, I don't know too much about these ground planes and how you know, what are the fundamentals that you should do when you are designing PCBs. So hopefully this is going to work just as is. And that's one more reason why I decided that if I ever do PCBs, I would probably go for one where I'm going to reuse existing components, like, you know, this sound module or the Arduino Nano, because those boards are probably engineered in a way that, you know, it needs to be like the components needs to be in a certain, you know, the crystal needs to be close to the microcontroller, or the, you know, the caps and the ground planes, that sort of stuff. So I would probably never, you know, design my own Arduino board completely, you know, using the bare chip. And of course, and I think this is also quite good, because if I, you know, make a mistake, and let's say if I fry the ESP, if I fry the Arduino, I can just unplug it and plug a new board in. And of course, I can use my existing links and, you know, purchasing sources to get some more Arduinos, rather than, you know, trying to figure out what's the best way to buy an Atmel chip. So that's my argument for this PCB, and probably most of the other PCBs that I'm going to be doing in the future as well. And what I thought I would do now is actually build the first board, the very first board from this one. And I have seen, you know, soldering videos from, you know, Julian and David, and initially I thought that those would be boring videos, but I quite like them. They are, you know, usually entertaining, and you always learn something new. So I thought that, you know, I will show you how it should not be done, because obviously it's going to be my first, so probably it's not going to turn out great. But yeah, I will just solder this board together and then see if it works for the first time. I think I have everything that I need. I'm going to use a TS100 soldering iron. I have some flux, a couple of connectors, pin headers, and a blue tack to hold all the components. And yeah, I am going to use a power tool battery to power the TS100. for which I've made an adapter. I think I've covered it in a separate video as well. So this is the board. So the board is here, and this big PCB holder, which actually I quite like. So I think what I'm going to do, maybe, oops, I just need a little bit more space. Maybe I'm just going to start with the Arduino board. So I'm going to remove the Arduino from the prototyping board. Now with a bit of blue tack. Yeah, and so I'm going to use sockets for all these, so everything in the board. So if I don't need it, or if I do something and I suspect that the component has gone wrong, then I can just, you know, replace it. And I'm not too worried about you know, the amount of space. I mean, the extra height that the PCB connector gives, because I have you know, plenty of space. Where is the flux? Okay, so let's turn the iron on. I set it to 300 degrees. I guess that's fine. Actually, I think what I should be doing is that I do a couple of pins on both sides. Then I can remove the Arduino so I don't heat it up unnecessarily. And then finish the rest of the soldering. I decided I'm going to just cut the parts where I'm not talking, because otherwise I think it's going to be fairly boring. Maybe it's going to be boring anyway. But let's give it a try. Okay, good. That's the Arduino thingy soldered. The next is probably going to be the soundboard, so I'm just going to remove it from here. And that's an 8-pin package, which goes, actually I know it goes this way. There is no marking. Oh no, I can see the marking of the USB, so that's there. Okay, and I already have, I bought these 8-pin sockets, so I just need to push them in. Okay, hold it down. Add a bit of a flux. I think I'm just going to solder this in while the chip is inside a socket. I'm going fairly fast. I don't think I'm going to heat. Actually, I realized I should have started with the simple components like the buttons and the, well, it's pretty much just the buttons, to be honest, and a rotary encoder. And I just have one more resistor, 1K resistor somewhere. Okay, I need to flip this because this holder is in the way. That's the only component which I placed quite close to the side of the board. I quite like this JQ6500 sound unit, mostly because it can play MP3s. So not only like, you know, old school 8-bit sounds, which always sound a little bit, you know, when they are low volume, that they always sound, you know, just 8-bit. There is always a hiss. So this is quite clear, and I think it has, what is it, 32 megabits, so 2 megabytes of flash, which is plenty. At 32 kilohertz, that's probably, you know, a couple of minutes of samples. I'm not going to use that much, so I don't think I'm barely using half of the memory. And it's so funny because I'm only using the pins on the left side, because the pins on this side are actually used for external triggers. So you can program it to play sounds via simple serial. So there is a library in Arduino IDE how to program them, or you can just ground some of these pins. So you have 4 pins which can, you know, trigger the first 4 sounds. So it's fairly easy to use them, and they, what is it? Probably £2, something like that. They are not expensive at all. Since I'm doing pins and headers, I think I'm going to do the screen next. So it's just simple 8-pin header. Okay, let's make sure that it's, you know, vertical and aligned. Okay. It makes it really fast to have this PCB holder, which can be flipped around. I think it's a nice design idea. Okay, this pin is done. Good. Maybe I would do these first. So I need a couple of 3 pins. One landed on the floor. And also another 3 pin for the power header. So oh no, that's fine. So the first goes in and the second goes in like, oops, here. Okay. As you can see, for both of these I think that's ground, so ground goes to the left pin, 5 volts goes to the other pin, and the middle pin goes to the OLED display. So to change the polarity, you either put a jumper in between the left and the middle, or the right and the middle pin. So that's how you would be able to control if that particular pin is connected to ground or VCC. Okay, let's solder on the main power header. So as you've seen on the prototyping board, I'm using the rotary encoder and also the 2 buttons to control it. But I thought maybe in the future I would like to have some sounds that I can just start immediately by pushing a separate button. Maybe a sound of a horn or like a steam engine whistle. And I thought that for that I'm just going to add this 9-pin header here. So I can connect a 3x3 matrix keyboard with a ground pin. And yeah, that's for future expansions. I haven't done the program for that. Actually, I've ordered a couple of these keyboards from eBay a couple of days ago. So it's probably going to take about a month to arrive. They are definitely not quick nowadays. I don't know why. Maybe it's... I've ordered a couple of stuff back in November, October time, and I guess they were caught up in the Christmas shipping frenzy because they took almost forever to arrive. I got some almost in February. But of course you can't really complain, because if you pick the cheapest shipping options nowadays, they put like a 19 or 100-day delivery, like, you know, as expected delivery date. So if it doesn't arrive in a month, you can't complain, because they say, well, it's going to take, you know, 100 days for shipping. But anyway, that's what you get if you want to do it cheap. Okay, we are almost done. I think we have most of the headers. This one as well. Everything seems to be secure. I don't see any issues with the soldering. Oh, 2 more headers here. I've used a 3-pin header, which is the amp output and also the speaker output. So I have the 3rd pin as ground, which I guess I really don't need. But as I said, this was my first project in the PCB design software, and I managed to find this 3-pin component, and I couldn't find the 2-pin component. So I thought, you know, what the heck, I'm just going to use 3-pin. And I'm just going to spend, you know, more time on my future projects to find a proper 2-pin header. But funny thing is that for all of the others, like the, you know, the ones up here, I only did 3 pins. So I guess, you know, that's just a learning curve. Okay, so, oh, is it off? Oh, okay. I think my power tool battery is flat. So I have these Einhell power tool batteries, or well, power tools. I have an impact driver and a drill, and they came with these 2 batteries. So it's 18 volt, 1.5 amp hours. So it's not a lot, but it gets the job done. And you know, I'm not really soldering for hours, so this also, you know, gives me plenty of power. And I just have, you know, fewer wires in my workbench. And I've done this 3D printed thing, which basically slips on the battery and connects to the plus and the minus terminals like that. And an XT60, and I got this XT60 to barrel jack also from Banggood for the TS100. So that's what I'm using. And this one is not fully charged either, but I think it's going to be enough for today. So what is it I'm soldering? Okay, I'm soldering those. Okay, so are we up? We're almost there, yeah. I set it to 300. That's the power. That's the speaker and the amp connection done. Okay, that looks good. When you heat up the this blue tech tends to stick on the components, but if you dab it, you can get it off fairly easily. So I think next I'm going to do the buttons, and I actually have a few more buttons, so I don't have to remove this from the breadboard. Even though, well, what the heck, I'm not going to use this anymore. And I've picked these, so I wasn't sure if I'm getting the same, you know, components on the design software what I have bought, and it seems to be a tight fit, but I will try to wiggle this in. Legs, I don't know, maybe I'm not sure, supposed to straighten these, but at least it's easier for me to get them in. Okay. Next is the rotary switch. I need to bend these bags back to its original position. Okay, so I might have bent these legs the wrong way, but it was difficult to get this one in. But I think it's sitting flush and securely against the board, so I should be able to solder this. Let me just add a little bit of blue tack just to be sure that it doesn't fall out. Then I flip the board over. Yep, that should be fine. The supports leg are just barely coming through. Maybe, I think, for the beginning I'm not going to solder them. I just want to make sure that everything works before I put an awful lot of solder into those pins, which would be definitely very difficult to get out if I need to desolder this component. And the only other thing we need is a 1K resistor. So you need this 1K resistor between the, I think it's the RX line of the I always say ESP, the Arduino and the soundboard. Hopefully I haven't made any issues while designing this board, and it's just going to work without any problems. So next is testing. So the Arduino goes in like so. Okay. And this one goes in like this. Oops. And the OLED goes in like that. Plenty of space for a bigger OLED screen. And I need to find my jumpers. So as you can see on this header, this one. So this pin is ground, 5 volts, and the middle pin goes into here, and here again it's ground and 5 volts, and middle pin goes into here. So I need a VCC here, so I'm just going to jump 5 volts. Oops! Shoot. Okay, so this stupid TS100 was slipping off from the holder and it was touching this damn battery case. And I could smell bad. You see, that's a bummer. Almost brand new batteries. Okay, 6 months old probably. So I need VCC here, so I've jumped the 5 volts in the middle, and for the other one I need ground. So I'm going to jump these two together. And that should be it. I need to make a few more wires for power and for the speaker, and after that we can test it out. So after successfully cleaning the soldering iron from the burning plastic residue, I created this simple cable for myself. So it's a small speaker terminated in a 2-plug or the 2-pin connector. So I'm just going to plug it in like so, a bit stiff. Okay, the wires go like that. And I think instead of powering it from the power terminals, I'm just going to plug in the USB here. And oh, we have a screen and it seems to be working. Let me put it this way so it doesn't shine. Yeah, that looks good. Oh, I can select that. So I want the intercity signal. I want intercity and I want platform 1. And what does it say? Yeah, something. I think I would need an amp for this one because it doesn't sound very loud. And there is a thing with these soundboards is that you can have, there is a setting for volume, and if you turn it all the way up, then sometimes they fail because the power is not good enough. And that's why it is definitely good to run it from an external 5 volt source, because I mean, especially on the breadboard, and well, even now, powering this via the internal regulator, which is on the, well, maybe it's not the internal regulator in this case. But anyway, so sometimes if I put the volume really high, then it just cuts out and reboots. So that was one more reason where I added the external amp. And I've actually ordered some really small, cheap amp. So I might just use an amp in the final product, but yeah, everything functionally works. Of course, I need to implement the keyboard in the future, but yeah, that's going to take some time. But I think that's it. I'm very happy with the way this turned out. I think this actual implementation, this station announcement is very specific. I don't think that you would use anything like that, but if there is a need, if somebody would like to have this, I'm going to clean up the code and I'm going to put it up on GitHub. And also the board is somewhat special, but if you need an Arduino with some controls and a screen and a soundboard, you might want to use that. So again, if you're interested in, I can give you the Gerber files so you can order your own board. Oh, I haven't mentioned, I think, well, obviously because it's a review, it was, I didn't pay anything for these boards, but it would have been 50 US with the DHL shipping. So I think it was 29 US for the 5 boards. So it's double-sided board. I've placed the order by putting everything into the default. So the default layer size and the default, whatever 2-sided board. I have to admit, I don't even know most of these details, but that's the beauty of it. You just, well, you learn you can design your board, but after that, if you are not, if you don't want anything special, you just basically put it into the code. It will generate a code for you, and then that's it. You can order your board. So it was the board itself was 29 for the 10, and this is 100. What is it? 101 times 72 millimeters. So it's not huge, but it's fairly reasonable size, I think. They usually advertise that you can get a board for a $5, and I think that's would be true if the board would be significantly smaller than this one, and you probably order only 5 and you use the cheapest shipping. But again, there is an option to get something really, really cheap in a small volume. which I think is absolutely fantastic. You can see a couple of thumbnails now on the screen, so if you are interested in watching some of my other content, just feel free and click on the thumbnails. There is also my lovely face here. By clicking that, you can subscribe to my channel if you haven't done it already. But that's all for now. Thanks for watching, and hopefully see you in the next video.